Okay, everyone. So we're going to be looking at building that actual duck class and then creating a main method in which we can create duck objects. So the first step to building the duck class is to create a new Java class. I'm just going to call it duck. And in our duck class, we're not going to use public static void main. Classes that are going to be objects don't need to have a main method. They're going to have what's called a constructor because we need to be able to construct duck objects. So before we do that, we're going to put in some of the data that we said this class needed to contain. So we're going to do private string name, private string type, and the other one was private int size. So we have three data members. They're global to the class: name, type, and size. I've made them all private because it's really good practice to make any of your data members private so that they're only contained within the class. And I'll show you how we can access that data still from outside the class. So I said we're going to create a constructor. The thing about constructors is, just add in some notes here. So the thing about constructors is that they're used to build objects of that class. Some things to note. Some things to note about constructors. First, they always share the name of the class. So this will be the only time that you ever have methods or functions that start with a capital letter, because usually only classes start with a capital letter, and your constructor has to have the same name as the class. Second, they don't have a return type. And third, because we're pretty much always declaring or creating objects of this class outside of this class, because this is the blueprint. Like when you have a blueprint for a house, somebody else takes that plan and builds the house. The blueprint itself doesn't build the house. Because of that, constructors are almost always public. Okay, so let's go ahead and build a constructor for this class following those rules. So it's public. It does not have a return type, which would normally be the next thing we did. It shares its name with the class, including capitalization. It's still a function, so it has brackets. And it does this. Now, all the constructor does is set up the initial values for the duck class. So let's say every time you create a new duck, it's going to say, okay, name is equal to Donald, type is equal to cartoon, and size is equal to 8. I didn't really make up a good size thing. I just want to show you guys that you could use strings in it. Okay, this is a pretty boring duck class because every single duck that we make is going to be of Donald Duck. So usually we're not going to be using a default of this, a default constructor like this. Usually we want to pass it a bit of information. When we create a new duck, we want to pass some information. So we could do a couple things. We could pass a single piece of information and set the rest to be defaults, or we could pass some of the information, or we could pass all of the information. So I'm going to go ahead and say, instead of doing this default constructor duck, we're actually going to require that when you create a duck, you specify the name, the type, and the size. We're going to do that by setting parameters for name. Yeah, I'll do it this way because CodeHS will do it this way. String type and int size. Now note that when Java looks at the parameters, it looks at them in order. So whatever the first string is that's passed, it's going to use that as the name. Whatever the second string is that's passed, it's going to use that as the type. And whatever int is passed at the end, it's going to use that as the size. So now here's something interesting. This variable is called name, and this variable is called name. So how do we differentiate the two? What we do is we say, because this, when we use name inside the function, it's going to look for the closest or most local version of that function, that variable name. So anytime we use name inside the duck constructor, it's going to go to the closest one, which is the one declared inside that function. So what we want to do is we want to say, okay, instead of doing name equals Donald, name equals type, name equals size, we're going to set name equal to name, which you can see might be a bit conflicting. So what we want to do is, since just name refers to the parameter, we want to say, but get the one that belongs to this whole class. But get the one that belongs to this instance of this class. So what we're going to do is we actually can just type this dot. So this dot name is getting the global version of name that belongs to the class. Go to this instance of this object, get the name from there, okay? Because each time we create a duck, it's going to have a separate name variable, okay? So now we can do this dot type, stores type, and this dot size equals size. So now we're storing the name, type, and size into the global variables. So now we've created an instance of a duck. Every time we create an instance, it creates a new name variable, a new type variable, a new size variable, and it stores that data in. There's lots of different examples of when we would want to do this, but it's very useful if, say, you're creating a non-player character in a game. Having a class and be able to just create NPC objects means you don't have to track all the information about each non-player character in your main game. You can just have literally an array or a list of non-player characters. Okay, so we have our duck string name, string type, string size, or int size, sorry. And we're going to write some of the functionality. So I'm only going to write the method for making a sound. I'm going to make it public so it can be accessed from outside this class. I'm going to have it be void because it's going to actually just print something to screen. I'm going to call it make sound. And it's going to it's just going to print quack. I'll show you how to do some of the other things that are... Okay, so we have this main method. It's partially built. We can construct ducks and we can make sound. At this point, we might want to go and test what we've done a little bit. So what we're going to do is we're going to create a separate class. This would be like our main game program, right? So let's say duck tester or duck creator, whatever you want to call it. In here, we are going to have a main method. So that's your public static void main. Okay. That gets past string arguments. In here, we're going to create some duck objects. So now that we've created the duck class, we can use it like a data type. So we can say duck, D1, actually let's call it duck1, equals new. We need that keyword new. That's what tells it to call the constructor. New duck. And we know that our duck constructor, what this is doing is it's calling this duck constructor. So we need to pass it some information. So now we could say Donald, cartoon, and size. We can also create another duck using that new constructor and the duck constructor. This one's going to be called Daffy. It's also a cartoon duck. Let's say Daffy's a bit smaller. He's a size 6. I don't actually know the ratio of size between Donald Duck and Daffy Duck, so you're going to have to deal with that. Okay, so now we have 2 ducks. For either duck, we can call the quack function, or the make sound function. So what I can do now is I have 2 objects, which means 2 whole objects have been created with their own name, type, and size, and their own version of make sound. Make sound's pretty boring at this point, but I can say duck1 dot make sound, And I can say duck2 dot make sound, and it should print quack, quack. I gotta reconfigure my Windows Defender. It's slowing down my build process. So it does say quack, quack, in fact. What we are going to want to do, though, is make it a little bit more interesting. So maybe we should have thought about this before, and maybe it makes a lot of sense to keep a separate string that's going to keep track of the sound that the duck makes. Okay? And I'm going to write a method for that that's public void set sound. We call these getters and setters. In this case, we're setting any variable. Anytime you're setting a variable, you can set it, use a set. In this case, it's going to need to take in a sound. I'm going to use that same this.sound equals sound. And then I'm going to go ahead and update my make sound to, instead of printing out just quack, it's going to print out sound. In my constructor, so right now, if I call make sound without yet having called set sound, it's going to by default break because the variable sound is a string that hasn't actually been created. So what I'm going to do is in my constructor, I'm going to set sound equal to quack. So by default, every duck quacks. But I could also set the sound and have a duck say something else. So here, we're going to leave them to make sound. We'll just run that and make sure that they both still quack. Okay, so they both still quack. Perfect. So now what I'm going to do is I'm going to say duck1 dot set sound to hello, Mickey. Because it's Donald Duck and he's friends with Mickey Mouse. So we're going to set his sound to hello, Mickey. We've only set duck1 sound, but we are going to now call make sound again on duck1 and duck2. And what we should see is that the first time they both quack, quack, then Donald's changes to hello, Mickey, and Daffy still quacks. So this is kind of the idea of being able to create objects. We can construct as many objects as we want from a single class, and the class handles all the functionality and all the data that's stored in each individual object of that class. So this is why we create what's called an instance of a duck. This is how we can use, go to this instance, call the function that belongs to that instance, or go to this instance and call the function that belongs to that instance. Same here. When we call duck1.setSound, it calls the setSound function, but only for duck1, not for duck2, which is why it only changes the sound for Donald and not Daffy. Okay, I hope this clarifies a little bit of how we can build a class that allows us to construct objects, and then how we would call that class in order to create actual instances of that object, and how we would access the things that those objects can do. Okay, I'll get into more in-depth videos and stuff in no time. I just wanted to give you guys a quick little introduction to the idea of objects.